A request from a student to go through a difficult simultaneous equations questions where one of the equations is a quadratic equation. So remember, a quadratic equation is an equation which contains squared terms. So as you can see here, we've got an x squared and a y squared term. Okay, so before we dive into this question, let's just go through some background information. So I mean, it's not really necessary in terms of, you don't have to know this information to answer the question, but by knowing this, it does tend to open your mind. Okay, so what we have here is this here is actually an equation of a circle. Because if I write down the formula for the equation of a circle, which is this, so it's x minus a in brackets squared plus y minus b all squared is equal to r squared. Okay, so what do all of these stand for then? So a and b are the coordinates of the center of the circle. So AB, the coordinates of AB is the center of the circle. That is the center of the circle. And R is the radius of the circle. Okay, so if you compare it with our example here, we don't actually have an A or a B value. Well, A and B in this case would obviously be 0, because if they were both 0, then we don't actually have any brackets. The brackets will disappear and we'll just be left with x squared plus y squared is equal to 29. So in this particular example here, this circle is centered at the origin, 0, 0. And the radius in this case is just the square root of 29, because remember the form of the equation is r squared. So if r squared is equal to 29, that means r is equal to the square root of 29. Right, so square root of 29 is approximately 5.4, I would say, because if we take square roots on, well, the closest square roots above and below, we've got square root of 36, which is 6, and the square root of 25, which is 5. 29 is roughly in the middle, it's probably slightly closer to 5, so I would say a good guess would be the radius is approximately 5.4. Okay, so what this will look like is it will look something like this. So if this is our xy plane or our xy grid, it will look something like this. So remember, the circle is centered at the origin and it has a radius of approximately 5.4. So it will look something like this. This is what our radius will look like. Remember, it's actually centered at the circle. So this is not an accurate drawing here because I'm doing it by freehand, but this is just to give you an idea. Okay, so if you look at this second equation now, this equation here is a linear equation, because if I were to move that minus x to the other side, we'll have 3 plus x. So remember, a minus x becomes a plus x on the other side. Remember, you change the sign when you move the term across the equals. So this is a linear equation here because it's in the form y is equal to mx plus c. M in this case is just 1, it's just the value in front of the x. There's no value there, so it's just 1, it's just 1x, and c is just 3. The only difference here is I've started with the c term and then ended with the x term. Okay, so this is a straight line graph, and what it would look like, if I were to draw it on this same graph here, it would look something like this. So this graph, as it has a positive gradient, it will go uphill, and it will cross at approximately 2 points. Those are your 2 points. So when you solve a pair of simultaneous equations where one of them is a quadratic equation, you will get 2 pairs of solutions. So you just need to keep that in mind, and the reason being is because of this diagram here. If you look at the linear equation, it crosses this circle at 2 points. Okay, so let's go ahead and solve this pair of simultaneous equations. So the way to solve it is you use elimination. So what you do is you always take this linear equation and you rearrange it to make either the y the subject or x the subject, and then what you do is you substitute it into there. And what you do effectively is you eliminate one of those variables. So you know, when I went through all that background information, when I showed you that it was a linear equation, what I did is I actually made y the subject here. So what I'm going to do is I'm going to take this, as we've already done it, I'm going to take this and I'm going to substitute it into our first equation. So remember, this y here it's like a value. Y is essentially a value. It's just whatever x is, add 3. So that x could be, let's just say it's 2, so then that would mean y would be equal to 5, or x could be 5 and therefore y would be equal to 8. But the important point here is this is just a value. So what I'm going to do is I'm going to substitute this into our y into the first equation, and what will happen is that, well, the y will be eliminated. So we've got x squared, that stays as it is, and then we have plus y, which is 3 plus x using our second equation, all squared, is equal to 29. Okay, so if we expand all of this out now, so we've got x squared. Let's just expand this bracket out now. So, okay, a quick way to expand this out is you can use my TAP, which is a trigger action principle. It's just a phrase to help you speed up the expansion of this bracket. So my TAP here is you square the first term. So you square the first term, you square the last term, and then you twice the product. So you square the first term, which is 3 squared, which is 9. Let's leave a bit of a gap for twice the product, and if you square the last term, it's just x squared, so you've got a plus x squared. Okay, the reason why I left the a space in the middle, because when you do twice the product, and twice the product just means you take the product of these two terms and you twice it, you double it. So 3 times x is 3x, and then you double it to give you 6x. Right, so that's just a quick way of expanding a squared bracket. So just remember that TAP, that trigger action principle, square the first, then square the last, and then twice the product. So you multiply the 2 and then double it, which gives you 6x. Okay, this is all equal to 29. Okay, so when we simplify all of this, so let's proceed to simplify it. So we've got x squared and we've got another x squared, so we've got 2x squared, so we have 2x squared. 2x squared, and we have a plus 6x. So I'm just concentrating on this left hand side here, so I'm just simplifying everything. The 9 is just going to be 9, so we've got a plus 9 here, and that's all equal to 29. Okay, as you can see, a quadratic equation arises. So what we'll have to do is we'll have to put this into two brackets. I mean, once we move this 29 to the left hand side, what we'll have is we'll have an example of a quadratic equation, and we'll have to solve it for those two solutions. Because remember I was saying earlier on that you will get two solutions from this type of question. So that's why a quadratic equation arises, because a quadratic equation has two solutions. Okay, bringing this 29 to the left hand side, what we're left with is 2x squared plus 6x. Okay, so this 29, when you bring it to the left hand side, it's positive on the right hand side, so it becomes a negative on the left hand side. So you'll have plus 9 minus the 29. So plus 9 minus the 29 goes down to minus 20, and that's all equal to 0. Right, so as we can see here, we have a quadratic equation where the coefficient of x squared is 2, so it's more than 1. So what you should do at this point, you should see if this equation can be divided, and because all of these constants are even, so you've got a 2, a plus 6 and a minus 20, you can divide the whole equation throughout by 2. So if I divided the whole thing throughout by 2, we're just left with x squared plus 3x minus 10 is equal to 0. Right, so obviously when we simplify it to the case just x squared, then it's a lot easier. So then what we do from here is we put it into two brackets. So if you think about the for method, it's going to look something like this. So remember, you set it out into this form, two brackets, and it's equal to 0. And what you're looking for is you're looking for two numbers that multiply to give you minus 10 and add or subtract to give you a positive 3. So after some thought, you will, the only possibility it could be is a 5 and minus 2. Remember, this is a minus here, so one of these brackets has to be a plus and the other one has to be a minus. Okay, so the only possibility, or the only combination it could be, is a plus 5 and a minus 2, because obviously 5 minus 2 gives us this value here, the coefficient of x. Right, so we've got, the two numbers are going to be a plus 5, so x plus 5 will be in one bracket, and the other bracket would put an x minus 2. Right, so we factorized our quadratic expression on the left hand side there, and now we can solve it. So remember, think about what this actually means here. This is just two numbers multiplied. Remember, this bracket, think of this bracket as just a number. X plus 5 is just a number, x minus 2 is another number. It's just two numbers multiplied together to give you 0. So what that means is, either for the whole thing to equal 0, either x plus 5 has to equal 0, or x minus 2 equals 0. Right, and from there that means if that has to equal to 0, or x minus 2 has to equal to 0, that means our only solutions are x, well, x has to be equal to minus 5 or plus 2. So that's our two solutions. X is equal to minus 5 or plus 2. So those are our x solutions, but remember, we have to sub it in to find the corresponding y points. Because again, if you refer back to my diagram here, obviously this point here, the x coordinate of this point is obviously going to be x minus 5, because it's in the negative region. This point up here, this point of intersection, is going to have an x coordinate of 2. As you can see, my diagram is fairly accurate. I know it was a sketch, but as you can see, it's roughly, it looks roughly good. Okay, so the x coordinate here is 2, is a positive 2. But what we need to do is we need to find the corresponding y coordinates of those 2 points. So what we do is we sub it into one of the two equations above, the original equations, and it's obviously best to use the second equation here, this y is equal to 3 plus x, because it's simpler to use. So subbing in what minus 5 into there, what that'll give us, it will give us when x is equal to minus 5, y will equal to minus 2. And when x is equal to plus 2, y will equal to 5. So it's kind of like the opposites to the solutions above. And those are a pair of solutions then. So one pair, which is this point up here, would be equal to, well, when x is equal to 2, as I was saying before, y will equal to 5. Which makes sense because this point here lies in the positive region, the positive x and positive y region, and this point here would correspond to minus 5 and minus 2. So that's minus 5 and minus 2. But as I said before, you don't necessarily have to do all of this bit here. So all of this bit here on the right hand side, you don't necessarily, don't have to do, but that's just to explain, the reasoning behind it. So why exactly do we have two solutions? Because if you really think about these two equations, one is a linear equation, the straight line, and the other one is a circle, so they're obviously going to intersect at 2 points. So this just gives you a better idea of the two formulas involved. But our final solutions is just when x is equal to 2, y is equal to 5, and when x is equal to minus 5, y is equal to minus 2. And of course you can sub these pairs of points into there, and they will always work out.